Now the question is, how many inflection points does a one parameter family like this have? So do you see an inflection point here? Where? At 0, 0, okay. And then when this starts shifting, when D hits 0, do you still see an inflection point? I say yes. The curve goes from being concave down to concave up. So because the curve changes concavity at 0, 0, this is an inflection point. Now what happens if I make this negative? That still looks to me like it's an inflection point. If I zoom in, that still to me looks like it goes from being concave down to concave up. It's more subtle, but I still think that this looks like it has an inflection point regardless of D at 0, 0. You agree? All right, so let's work through that one algebraically. So we had 3x, we had g prime of x was 3x squared minus d. And so we have g double prime of x is 6x. And so we want to solve g double prime of x is equal to 0. And then we want to make a sign chart for g double prime of x. Solving 6x equals 0 is just x equals 0. And then making our sign chart, we'll have a value at 0. And we will test x. We can test x equals -1 and test x equals 1. For this is -infinity to 0 that we're representing, and this is 0 to infinity that we're representing. So if I test x equals -1, g double prime of -1 is equal to 6 times -1, which is negative. So g double prime of x is negative. So g of x is concave down. And then if I test x equals 1, g double prime of 1 is 6 times 1, which is positive. G double prime of x is positive, which is concave up. So regardless, this didn't depend on D at all. Regardless of the sign of D or the value of D, g of x is concave down on -infinity to 0 and concave up on 0 to infinity. And that confirms what we saw when we were playing with the graph.